Hey everyone, hope all is well. Today we're going to have our video lesson for Unit 11, Lesson 6, which is on factoring, something that we call difference of squares. Okay, and I want to bring to notice two vocabulary words. First word, difference. Okay, so when we think about what that word difference means mathematically, remember that difference means subtraction. Okay, so what we're going to see in our problems today is we are going to be doing some sort of subtraction in the initial problem, and that's going to be kind of our first sign to say this is a difference of squares problem. Now, the second word we want to call to our attention is squares. What does it mean for something to be a square? Essentially what that means is this: the square root of that value is a whole number. Okay? So a square is a number whose square root is a whole number. So for example, 16 would be an example of a square, because if I take the square root of 16, that comes out to be 4. There's no decimal or anything like that. But if I were to take the square root of 20, that would be 4 point something, which means that 20 is not a square. Okay, so what we're basically going to be seeing is something where we are subtracting, hence the word difference, and we're going to be utilizing numbers that are perfect squares, which means when we take the square root of it, we get a whole number, no decimals. Okay, so what we're going to start by doing is an introductory and review problem at the same time. If I've got this double distribution, a plus b times a minus b, we know that our first step would be to multiply the a through to everything distributed. So a times a is a squared. Next we would do a times the b, and we've got that minus sign, so it would just be minus ab. And we're now done distributing the a. So now we would distribute this plus b, or this positive b. Okay. B times a is ba. And lastly, b times negative b is minus b squared. Okay, so that's our first step. Now, what I want to focus on is this middle set of numbers right here, this minus ab and this plus ba. Remember that what we're doing with those two values is we're actually multiplying them together. Now, just as we know 2 times 3 is 6 and 3 times 2 is 6, we can see that the order in which we multiply two values doesn't matter. It's going to end up with the same result. So what I'm going to do is I'm just going to rewrite that a squared, and I'm going to keep this minus ab because I like that alphabetical order, a first, b second. But I'm just going to switch the order of ba to write it as ab. It means the exact same thing. A times b would be the exact same as b times a. Then I'm going to bring down that minus b squared. And now if I highlight this middle section again, we should notice something very unique or very special. If we have a minus AB and a plus AB, hopefully we recognize that those are going to cancel out, or they're going to add to 0. So this is gone and this is gone, and what we're left with is a squared minus b squared as our final answer. And let's make this full circle and take it back to where we started with today's lesson. We have a difference, because we are subtracting, of squares. We have a squared and we have b squared. We've got two squares, a squared and b squared, and we are subtracting them, hence taking the difference. Okay, so this is what our first problem is going to look like, or all the problems for today. It's just going to be a squared out front, a squared value at the end, nothing in the middle. Okay, so what we just saw before is this pattern, this relationship, that if we have a squared minus b squared, where that came from was a plus b, a minus b. Okay, now in our warm-up we started with this, finished with this. For today's practice problems, we're going to start with something that looks like this and work backwards, factor it to look like this. So here's the real nice shortcut to it. Essentially what we're going to do is this. when we have this difference of squares, notice there's no like bx in the middle, okay? What we have is our first set of parentheses, second set of parentheses. We are going to take whatever the square root of a is, and we're going to drop it in right here and right here. So for example, the square root of a squared is just a. This square and that square root cancel out. Likewise, I'm going to take the square root of b squared, which is, again, these would cancel out, b and b. And then the only thing we got to be careful of is, even though it's a minus in the problem, we notice this pattern here. One of my signs is plus, one of my signs is going to be minus, and that's what caused these two middle terms to cancel out. Okay? Plus, minus. So what we'll do is we'll take a look at a couple of these on the next slide. Feel free, if at any point you feel comfortable with this and want to try them on your own, to pause the video, and then once you have the answers on your own, go ahead and replay the video and see if you got those correct. Okay, but we'll do a couple together first. One thing I want to talk about very briefly is, how do I know when I have a difference of squares problem? What's my thing that I look for in order to recognize that? Well, first of all, you notice I have my x squared term, and I have my, for lack of better terms, my c term, like when we had our ax squared plus bx plus c. Okay, we have this number without an x. We have this x squared term, but we don't have that bx anywhere in the middle. So that's kind of our first sign to say this may be a difference of squares problem. The second thing that we're going to hopefully recognize is the idea that x squared is a perfect square. If I take the square root of x squared, I just get x. 4 is a perfect square. When we take the square root of 4, we get 2. And then lastly, we have that minus sign, the difference. So we have a difference of squares. So when we go to factor this problem, if we can recognize this is a difference of squares problem, we can make our two sets of parentheses. The square root of x squared is just x. So that's the first term in each set of parentheses. The square root of 4 is 2. So we put a 2 at the end of each. Then lastly, as far as the signs go, remember we want that middle term to cancel out, which means I'm going to make one of these a positive 2, one of these a negative 2. And that's going to be our final answer. You can always check this answer to see if it's correct by doing the double distribution. So for example, if I were to do x times x, that would give me x squared. If I do x times negative 2, that's negative 2x. 2 times x, positive 2x. Positive 2 times negative 2, negative 4. Sorry if you can hear my daughter screaming in the background. We're just putting her down to bed. She's not too happy right now, but she'll be all right. Anyways, we see this minus 2x and this plus 2x in the middle of the problem. And so those would end up canceling out, and we get right back to our x squared minus 4. Now again, that's not my final answer. X squared minus 4 is what we started with. We were just doing this double distribution to show that we did the problem correct. X plus 2, x minus 2. Okay? So let's take a look at another one here. We've got x squared minus 25. Again, we see that it's a difference. We're taking a subtraction of x squared, which is a perfect square, and 25, which is a perfect square. So if I take the square root of x squared, I get x. If I take the square root of 25, I get 5. So inside my parentheses, I'm going to start with an x for both. I'm going to finish with a 5 for both. And then I'm just going to have the alternating signs so that the middle term will cancel out. Plus 5, minus 5. Okay. So I'm going to ask that you try to pause your video right now and try example 3, get your answer, in your notes and then replay the video or resume it and see if you got the correct answer. Okay, let's see how we did. We have a difference of squares. The square root of x squared is x. The square root of 100 is 10. Therefore, I'm going to have x plus 10, x minus 10 as my final answer. Okay? So hopefully we got that one correct. Now, these last two look a little bit different because they don't start with just a regular x squared. Okay? In number 4, we have 4x squared, and in number 5, we have 9w squared. But what we hopefully do notice is it still has that x squared, or that w squared in this case. But in addition to that, 4 is a perfect square. 9 is also a perfect square. We have a difference. We are subtracting. 9 is a perfect square, and 25 is a perfect square. So we still are going to do the exact same thing, except a little bit different look to that first one. Okay, if I've got 4x squared, I'm still going to take the square root. Now, I just remember, as we've talked about before, we treat our number separately from our variables. So I would take the square root of 4, which is 2. I take the square root of x squared, which is x. So, in my parentheses, that's going to be my first term. 2x is going to be at the start of both of them. Now, as far as the second term goes, I'm going to take the square root of 9, and the square root of 9 is 3. So I'm going to have a 3 at the end of each of those. And then we just want to remember to alternate our sign. Plus 3, minus 3. 2x plus 3, 2x minus 3 is our factored version of 4x squared minus 9. Okay? So when we go to do our last one here, again, we start by taking the square root of 9w squared. Square root of 9 is 3. Square root of w squared is w. So I'm going to start with 3w for each. Square root of 25 is 5. So I'm going to have a 5 at the end, plus, minus to cancel out the middle term. And there is our difference of squares factoring. Okay? So, long story short, we first have to be able to recognize. That's the most important thing, because over the last couple lessons, we've talked about all these different factoring strategies. So we want to be able to recognize when we use each. And after this, we're going to go into a mixed review, and I'll kind of reiterate what are we looking for each, or how do I know when to use that AC method? How do I know when to factor with difference of squares? How do I know when it's just a regular GCF problem? Okay, so we're going to talk about each of those. But when we have difference of squares, we want the first value to be a perfect square, we want the second value to be a perfect square, and we want to be subtracting them. When that's the case, we do the square root of the first, square root of the second, and then flip the signs on the inside. One's plus, one's minus. Okay? So now you'll notice the rest of the way is mixed review. And we've got 1, 2, 3, 4, 5, 6, 7, 8 of these problems. Okay? So what we're going to talk about in each is how do we know what type it is, what type of factoring we do. Do I do GCF? Do I do AC method? Do I use difference of squares? Okay? So as we look at each problem, we'll kind of talk about what we look for and how we know. So right away, when I see this first one, I see that there's only 2 terms, right? So it's not going to be our, and I'll write a little list here. These are our 4 options. It could be GCF. It could be x squared plus bx plus c. It could be ax squared plus bx plus c. Or it could be difference of squares. So one thing I can tell right away is because there's only 2 terms, 10p to the 10th and 35p to the 9th, I know it can't be either of these 2 middle options. There's only 2 terms. So that leaves me with either GCF or difference of squares. Well, it can't be difference of squares because we are adding, plus 10 is not a perfect square, and neither is 35. So this tells me that this is just a regular GCF problem. What I want to do is figure out what can I take out of each of these. So we'll start with the numbers. When I think about the number 10 and the number 25, what factor can I take out of each of those? And that would be a 5. After that, I look at the p's, or the variables. I have 10 p's in the first, I have 9 p's in the second. So what's the most number of p's I could take out of each? That's obviously going to be 9. So I'm going to take p to the 9th out. So my GCF is 5p to the 9th. And then what we'll do is we'll figure out what's left over after we factor that out. Okay, so 10 divided by 5 is 2. And if I've got p to the 10th divided by p to the 9th, there's just 1 p left over. Okay, plus 35 divided by 5 is 7. P to the 9th divided by p to the 9th is just 1, so it would be times 1 at the end, which we don't need to write in. And there's our final answer. 5p to the 9th times 2p plus 7 inside the parentheses. Okay. Next one here, I'll make my little list again. GCF, x squared plus bx plus c, ax squared plus bx plus c, and then difference of squares. So in this case, I see again, there are just 2 terms, so it can't be either of those 2 middle ones because those require 3. Okay, I do see the subtraction sign in the middle, so maybe it is difference of squares. 9 is a perfect square, so maybe it still could be difference of squares. However, 3 is not a perfect square. So that eliminates this option. And again, this is just going to be a GCF problem. Okay? So what we'll do is we'll take a look and see. With a -3 and a -9, what could we take out of each of those? And that's going to be a -3. When it comes to the variables, the first one has a squared, but the second one has no a's. So I can't take any a's out of both. So now I'll start my parentheses. If I do -3 divided by -3, I'm just left with 1, which I really don't need to write if there's just 1. Then I'm going to do a squared divided by, well, there's no a's to divide by, so it just remains as a squared. After that, we're going to do -9 divided by -3, and a negative divided by a negative comes out to be a positive. 9 divided by 3 is 3. So our final answer comes out to be -3 times a squared plus 3. Okay. As we move along to the next one, I'm not necessarily going to write out the list of our 4 options on the side anymore. If you want to continue to do that, I think it's a great strategy. But for the sake of time, I'm going to save us a little bit of that. Okay, we see that there's 3 terms. Okay, so my guess is it's going to be one of those 2 middle ones. And in fact, since there's nothing in front of that variable, this is just going to be our regular x squared plus bx plus c factoring. So this is where we kind of did that x factor, or those diamond problems before, right? I want to know what 2 numbers are going to multiply to -7 and are going to add to -6. Okay, I want to think about what 2 numbers are going to multiply to -7 and add to -6. So because we're getting a negative when we multiply, that means one of the values has to be positive, one has to be negative. So my options are either -1 and +7 or +1 and -7. If I want it to result in a -6, then that means I want to go with the option of +1 and -7. Those are my 2 factors. Therefore, when I go to factor this, I'm going to have r plus 1, and then I'm going to have r minus 7. When I double distribute, r times r is r squared. 1 times 7, r times negative 7 is negative 7r, but then I would be adding 1r to that to get the negative 6r, and then positive 1 times negative 7 is our negative 7. Okay. As we take a look at the next one, again we see it's just our typical quadratic, x squared minus 11x plus 28. So again, I want to multiply to positive 28, and I want to add to negative 11. Okay, so as soon as I see this negative in front of the 11, that tells me I'm going to have negative factors. Because if I do a positive times a positive to get 28, there's no way I could have two positive numbers that add together to equal a negative. So what I'm going to do is take all the factors of 28, but make them both negative. So negative 1, negative 28 comes out to be negative 29. That's not what we want. Negative 2, negative 14 come out to be negative 16. Okay, not what we want, but getting closer. 3 is not a factor of 28. 4 is. Negative 4 and negative 7 come out to be negative 11. That's what we wanted. So my two factors, x minus 4, x minus 7. Okay, now when we get to this next review problem, I can see that there is a number in front of our n squared. So this is our lesson 5, which many of you emailed me with questions about, which is great. This is, in my opinion, one of the tougher lessons overall in Algebra 1. And it does take a little bit of time and practice to get used to. So hopefully seeing it a couple more times here may be helpful. When we see this number in front of our x squared, or in this case n squared, we want to first get rid of it so that we can make it look more like a problem we're comfortable with. So what we do is we take that 6 and we multiply it to that end value, in this case 2. So 6 times 2 is 12. From there, I'm going to rewrite this exact same problem, but now that 6 is gone. I borrowed it over to the end. N squared plus 7n plus, now instead of the 2, we did 6 times 2 to get 12. We do this so that way we can factor a lot easier. So I'm thinking now, what two numbers are going to multiply to 12, add to 3? Well, 1 and 12 is 13. 2 and 6 is 8. 3 and 4, 7. Perfect. So what we do now at this point is we rewrite our original problem, 6n squared. But if you recall, I'm going to take this plus 7n and I'm going to split it up into these two factors. So instead of plus 7n, I'm just going to split it plus 3n plus 4n, right? Because 3n plus 4n is that original 7n. So we didn't change the problem, we just split that 7n. And then lastly, plus 2. Now, the reason we split that is so that now we can practice our GCF factoring. I'm going to clump the first two terms together and the last two terms together, and I'm going to ask, what can I take out of each set? So in the first set, if I look at the numbers, I have a 6 and a 3. I could take a 3 out of each. I have an n squared and an n. I could take a single n out. So then 6 divided by 3 is 2. N squared divided by n is n, plus 3 divided by 3 is 1. I don't need to write that in. N times n, or n divided by n, is 1 again. So I essentially do need a 1 in there to hold that place. So I have 3n times 2n plus 1. Now I'm going to do the same thing over here. What can I take out of both a 2 and a 4? Obviously, that answer is going to be a positive 2, so I'll put a plus 2 here. 4 divided by 2 is 2. N divided by, well, I didn't take an n out, so I keep that one n there. Plus 2 divided by 2 is 1. Okay, and now we are almost done. We can see, if I look inside the parentheses, each of these terms has a 2n plus 1. So that ultimately becomes my first factor. 2n plus 1 is part of each of those. Now what's left over is what's on the outside, 3n plus 2. Okay, and there's our final answer. So a lot more tedious, right? A lot of steps to this one, and that's why I feel this is one of the more complex lessons we have in all of Algebra 1. But the more practice we get with it, the more comfortable we will get. It does take time, okay? So if you're not there yet, be patient, keep working with it, you'll get it. Okay, so we do one more of those. Again, we see 3 terms. I have a number in front of that squared variable. So this is going to be 9 times 4 to get 36. I rewrite the original problem without the 9 now. B squared minus 20b, and I'm going to replace that 4 with the 36 we just got, just temporarily while I factor. So I want to think what numbers are going to multiply to 36 and add to negative 20. Using that same philosophy, the only way to multiply to get to a positive number and add to get to a negative number is if both factors are negative. So negative 1, negative 36 is negative 37, no good. Negative 2, negative 18, negative 20, perfect. Okay, so now I'm going to rewrite the original problem now that I have my 2 factors. 9b squared minus 20b is going to get split into these 2 new factors. Minus 2b minus 18b plus 4. Okay. From there, we group. First 2 together, second 2 together. So when I look inside this first set of parentheses, there is no common factor between 9 and 2, but there is a b squared and a b, so I'm going to take that 1b out. The 9 has no factor, so it stays. B squared divided by b is b. Likewise, that minus 2 does not have a factor taken out of it, so it's minus 2. B divided by b is just 1, so we are good there. B times 9b minus 2. Okay, when we go to the next set, we talked about this the other day. We don't want to have that negative out in front of the variable, so we're going to factor that negative out. Okay, and then as far as numbers go, 18 and 4, I could take a 2 out, and that would be it. So I'm going to take a 2 out of each, and then I'll do our division. Negative 18 divided by negative 2 is positive 9. B divided by, well, there was no b, so we keep it. And then I have positive 4 divided by negative 2 is negative 2. And sure enough, we can see inside our parentheses 9b minus 2 in each. Okay, that's our verification we had it correct. So 9b minus 2 is our first factor. Second is whatever is left over on the outside, b minus 2. Okay, and that is our AC method. That is how we factor a squared or ax squared plus bx minus c. Lastly, we're back to 2 terms. I have a difference. I know x squared is a perfect square. I know 16 is a perfect square. So this is just more practice from what we did today. Okay. When I see that difference of squares, I take the square root of x squared to get x. I take the square root of 16 to get 4. And then remember, we want to cancel out that middle term, so I'll have a plus 4 and a minus 4. Lastly, 25n squared minus 16. 2 terms, difference, 16 is a perfect square, 25 is a perfect square, and then n squared is obviously a perfect square. So this is another difference of squares. I can fill in that plus and minus right away. Square root of 25n squared. Well, the square root of 25 is 5. Square root of n squared is n. So that goes in the first spot for each. And then square root of 16 is 4. So that goes in the last spot for each. 5n plus 4, 5n minus 4. Okay. So a lot of problems here, but really good review of our different factoring methods. GCF, regular x squared plus bx plus c, ax squared plus bx plus c using our AC method, and our difference of squares. Okay. If at any point you have any questions, of course, feel free to send me a message in Schoology or email, and I will do everything I can to best assist you. Otherwise, go ahead and start working on those practice problems that are given. Get that submitted, and you're all good to go.